Do strike back first. What question do you want to see? Do go over? Had questions about? 3, 4, that 1, 1, 3, 3, 1, 3, 4, 2, 5. 1, 3, 4, 2, 5. That was all of them. Okay. I had one of these on my desk. Can you see it? One, you have to describe the slope. So this is going up and to the right, so it has to be positive. So describing slope, even if you have Desmos, you'll still need to know how to describe it. And then the calculating, you could put this in Desmos, but you already have the graph, so that wouldn't be necessary. If you counted it from the 2 blue points, that would be up 1, 2, 3, 4 to the right 2, and you would simplify. Or you could have saw that there was another point. Either way, your slope was 2. So you need both things in order to get that full point, positive and m equals 2. 2 can be done in Desmos. 3 we're going to set up, and it can be done in Desmos, and then the other 2 can be done in Desmos. So if I were to put in the original, you could, since you're solving for y, find your y-intercept and look for your slope. So y-intercept at 4, slope looks like it's going down 2 to the left 3. So that would give me this equation, y equals 2/3 x plus 4. So that's what your solve for y equation should be. If it was solved for x, it'd be a little different, because you'd be able to find your x-intercept, but not necessarily the rest of it. For 3, Nick and his friends rented a canoe for 3 hours and paid $45. How many hours does it cost per hour to rent a canoe? So that's what you don't know. Some variable cost per hour. But you know he rented it for 3 hours. So you would multiply that by 3. Is that equal to 45? And either solve it by dividing, or if you wanted to double check yourself in Desmos, you could put that in and zoom out, and it would give you the answer of 15 either way. And then make sure that's $15 since we're looking for cost. Questions on 1 through 3? For number 4, because it says write the equation, and we've been doing this a lot, anytime it says write the equation, you should be putting in y equals mx plus b, putting in your ordered pair, and then you knew, it told you it's parallel, so the slope has to be the same, it has to be 2, and it would have to go through this point, so you would adjust your y-intercept, so I already made it 7, but you would adjust it until it goes through that point, which was at 7. So then that equation would be y equals 2x plus 7. And that would be the one that's parallel to the original that goes through that point. Questions on that one? Then the last one was an inequality. So to check yourself, it should be a solid line, y-intercept at -3, slope of -2, shaded above. If yours does not look like that, fix that. Questions on any of those? to try and go through as many of the SOL standards as possible. So starting with 6c, that was your graph the line. So this is the algebraic work for it. You would subtract 8x to both sides, divide everything by 4, and get y equals negative 2x plus 5. If you were doing that in Desmos, you could have just typed in the original. It would give you your y-intercept and your x-intercept. You could plot those 2 points, or find this. You could count the slope and do it that way. Anyone need or want to see that in Desmos before we move on? I don't think we can remember, but whatever 6c is. Wow. So I put in the original, it would give me a line, and then if I count what that y-intercept is and find my slope, it should give me this. Or you could have solved it and made sure that they match, and then graphed it like that. Either way. A cannot be done in Desmos. This is something you have to know. So whether it's a function or not, you have to know that. So 1 was yes, 2 and 3 were no, 4 was yes. Questions on any of those? B also really can't be done in Desmos. Like, you can use the graphs to help you count the domain and range, but you have to know what you're doing. So for 5, the range has to be a list of ordered numbers. C was the only one with a list of ordered numbers that were y values. And 6, the domain was all real numbers. C and D can be done in Desmos completely. So I'll give you all the answers, and then any we want to see in Desmos, we'll go back and look at those. So if it's looking for zeros, those are your x-intercepts. So you can graph each of these and see which ones fall on the x-intercepts, and write those as ordered pairs. So 7 was 2, 0, 10 was also 2, 0, 8 was 4, 0, 11 was 6, 0, 9 had 2, 8, 0, and 5, 0. 12 was negative 2, 0. We're going to talk more about this, like 2 distinct zeros, next class, but if it crosses the x-axis twice, it would have 2. When you graph each of these, the only one that has 2 is C. And then the others ask for what are the zeros, so what are the x-intercepts. 14 was negative 1/3 and 3/4. 15 was negative 1/2 and 2/3. And 16 was negative 4/5 and positive 4/5. It depends. So the question will either say leave it as a rational function or leave it as a fraction, or it won't say, and then it shouldn't matter. If it's a repeating decimal, it's probably going to say leave it as a fraction, or we'll want it as a fraction. Are there any of those we want to see in Desmos? See what it looks like. Which one? 16. So if you put that in, you can click on those x-intercepts. If it asks for fractions and on the graph it gives you decimals. If you put in that decimal, you can change it to a fraction. That way you can put in that answer. But if it doesn't say, then it shouldn't matter. Any others we want to see in decimals before we move on? A.7d is intercepts in general, so your x and y, and you just have to know which they're asking for. So for 17, the x and y intercepts of this function was d. You could have done a couple different things. Graphed the equation, saw which one matched. Looked at the equation, saw that this had a y-intercept of 8, and there's only one that matches that description. Or did it algebraically. Any of those methods would work. 18, you had to plot the x and y intercepts, so literally just put points where the x intercepts and where the y intercepts are. If you got a question like that on the SOL, it would have like a dot. It would have dots, and it would say basically the same thing. Or plot the x and y intercepts, or it might just say one or the other. 19, we're going to talk about next class. But the two factors that would create this are these two. Of these three, 19 and the first one are the only ones we can do in Desmos. Do we want to see either of those in Desmos? The first one, yeah. Okay, so what I did is I put in the original function, and I start putting in all the values. So if I want to do it that way, I would be looking for the ones that are on this, and 0, 8, and negative 2.67 or negative 8/3 were the two. So D was that answer. You could have also just looked at it and said, okay, my y-intercept is 8, my x-intercept is like negative 2 something, and figured out which one matches that. I'm going to have you guys start writing this down, and that'll probably be all the time we have for before lunch. So those are the vocab you guys need. I'm going to have you start writing this down. And then if we need to finish it when we get back from lunch, we'll do that. So we are now in Unit 11. There's only one more unit after this. But Unit 11 is quadratics. We've talked about these before, but not exactly. We haven't said these names and things like that. Matthew, you're writing this down? Okay. All quadratic equations are written in this format. Y equals ax squared plus bx plus c. When they're graphed, they create a U-shape called a parabola. U-shaped curve. Okay. Try to the best of your ability to graph these two. It doesn't have to be perfect. Just draw a rough sketch of that. Anyone still writing down these two things? If your A value is positive, your parabola, the U shape, is going to face up. If it's negative, it's going to face down. And then there are some specific characteristics we need to know about a quadratic. One of them is the axis of symmetry. That is a vertical line that divides the parabola into two equal parts. So we're going to draw it in the first couple times, but then you won't really see it. It's really invisible. It just shows that it's cutting it in half. This is the formula to find that. X equals negative b over 2a, so make sure you write that. And after we get that, it'll end up being x equals, which makes sense. It's a vertical line. Anyone still doing these graphs? Okay. The other characteristic is a vertex. That's your turning point. So basically where it goes up and then comes down, or goes down and then goes up. And that's either going to be the lowest point or the highest point. You hit new session, Annabelle. Lowest point is your minimum, highest point is your maximum. New session. And those are always going to be written as ordered pairs, x, y, x, comma, y. When we come back from lunch, we're going to use these and figure them out and do examples with them. Anyone still need any of this? It's going to be an example. We're going to do this together. Okay, so we're going to do a couple of these examples together so you can get a feel for how to do the work, how to do the rough sketch, and then we'll actually graph some. So we have to find our axis of symmetry first using that formula from above, x equals negative b over 2a. If you need to / want to, you can label each variable so you know which one is which. What comes in front of, x squared is a, what comes in front of x is b, and the last one is c. So you're going to use those numbers. X equals negative 8. So the negative is always in your formula, even if it's already negative. Over 2 times, what's your a value? 1. And then you would simplify. What would that simplify to be? Negative 4. So that's where your axis of symmetry would be. X equals negative 4. And then you're going to use that to help you find your vertex. So you're going to take that negative 4 and you're going to put it in for each of your x values. And whether you calculate that by hand or put everything all together in your calculator all at once and figure out what that is, doesn't matter, as long as you show how you set it up. Find what that y value would be. If you were looking at me, you need to be calculating this. Negative 3. Double check that because I don't think that's right. Negative 1. So if you get numbers like negative 33, double check your negatives that you use parentheses, all those things, because they should be small numbers. So you're going to use the x value from your axis of symmetry and the y value you found from this, that negative 1, to write your vertex. And then we're going to do a rough sketch. So draw in a x and y axis. Plot your vertex point. We're going to draw like a dotted line, vertical line through that point. That's going to show your axis of symmetry. And then in order to sketch this, our A value is positive. Would that make it face up or down? Up. Because A is positive, this is going to face up, so from your vertex, you're going to draw like a U. Doesn't have to be perfect, but try to make it look like a U, and draw arrows at the end. Isabel, did you write this down? Before we go on to the next one, what questions do we have on this? Right now, we're just doing a rough sketch. When we actually graph it, you'll know how far. So right now, it doesn't matter. As long as it looks like a U, you're okay. Okay, go on to the next page. We're going to do a few of these examples and then actually go on to graphing. So let's start with number 2. If you want, so you're not flipping back and forth, write your formula up here. X equals negative b over 2a. And then let's do that to find our axis of symmetry for number 2. You can label your A, B, C if you want. This time your A is a -1. What would your axis of symmetry be? Teacher? X equals 5. So then we're going to take that 5 and put it in for all of your x's. So find your y value. Find that y value so we forget. So your vertex should be 5, 2. You can draw in your rough sketch, draw in your x and y axis, plot your point. Draw in your axis of symmetry. And then would this face up or face down? Your A value, is that positive? Is it negative? Is this positive or is this negative? Down, because it's negative. So from your vertex, draw an upside down U. So that's a good way to check yourself when you start graphing these. If your A value is positive but yours is facing down, something's wrong there, or vice versa. What questions do we have on that? So this one, your A is negative. That's why it's facing down.
Oh.
Okay, we're going to skip down to number 8. What is different about this problem? There's no C. So we're going to see if that affects anything. So still do your axis of symmetry. What would that be? Positive 2. So x equals 2. And then put that into all of your x values to find your y value. What would your y value be? So your vertex is 2, 4. Draw in that sketch. Would that face up or down? Down. Okay, so if you don't have a C value, it doesn't really change anything. You have less numbers to put it in. 4 into the original equation is about it. And then we're going to try one more. 10. What's different about that one? There's no B, so let's see if that does anything different. When you find your axis of symmetry, what would that be? If we don't have a B, you have to put in 0. So if we're putting 0 in, what would our axis of symmetry be? 0. If it's negative 0 or 0 over anything is still 0. So that's one thing that's nice. Anytime you don't have a B value, your axis of symmetry is always going to be 0. And then if we were to put that in for x, what would your y value be? Nature. 8. That's another nice thing. Your axis of symmetry will always be 0, and you could really just look at that last number. That will always be the y value. So then when we draw in that sketch, they're going to face up or down? Down, because A is negative. I didn't draw in my axis of symmetry, but it's like on the y-axis. Okay. So now we know what the basics are, how to find the axis of symmetry, vertex, how to roughly sketch it. Now we're going to actually graph it. Go on to the next page. Steps are basically the same. Find the axis of symmetry, find the vertex. And now we're going to be given a table. You're going to fill out the table and use our calculator to do that, and then graph it from there. So let's find our axis of symmetry here. What would that be? 0, because we don't have a B value. And then if we were to put 0 into the original, what would our y value be? Also 0. So we have our vertex 0, 0. We're going to take that point and put it in the middle of the table. And you're going to fill in your x values. You're going to go backwards and forwards. So backwards, -1, -2, forwards, 1, 2. And then you have two options. You could take each x value, -2, -1, 1, 2, and put it in like we did for 0. For this problem, we wouldn't take that much time, but for the problems that have 3 terms, that might get a little lengthy. So I'm going to show you how you can do that in the calculator. So in your calculator, in y equals, clear out whatever's there, type in x squared. And then we're going to go into the table, second graph. You may have to scroll. There we go. And we're looking for these 5 values so we can fill in the table with those y values. -2, 4, -1, 1. What's nice about this is once you have half of the table, the other half just repeats. So this should be 1 and then 4. Then we're going to use those 5 points and plot them on the graph. -2, +4. No. -1, 0, 0, 1, 1, 2, 4. So this will control how far out you go. And then from your vertex, kind of make that U shape again. We did not draw in the axis of symmetry, but you could see where it is. We said it was x = 0, so right here we can see that that splits it in half. You don't have to draw that in, but if it helps you see that it cut it in half, feel free to do that. Do we have any questions on how to graph it before we find domain and range? So what's nice is we've done domain and range already. It's really the same. It's just now we're looking for specifically on the quadratic. So what would your domain be? Looking left to right. What's the furthest point to the left? What's the furthest point to the right? Does it stop at -2 if it has arrows? All real numbers. So you can write it in either notation, interval notation, -infinity to infinity, or set builder notation, XER. For our range, what's our lowest, what's our highest? What's our lowest value? 0. Cameron, what's our highest? So it's going to start at 0, and because that's a closed point, that would be bracket 0 to infinity, parentheses, or everything above 0. So y is greater than or equal to 0. Now, if you wrote both, that's fine. Moving forward, you'll just need one of them. Do we have any questions on domain and range?
How does it tell if it's a vector or not?
If it's a closed circle, so like this was a point here, if it was open, it would be parentheses. And then infinity and -infinity is always parentheses. Other questions on that one? We're going to do one more of these. I'm going to show you a trick in the calculator, move on to something else, show you something in Desmos, and then you'll have time to practice. So we're going to do number 3. So let's find our axis of symmetry. Be careful because it has the negative in front, so you'll have -8. Find what your axis of symmetry would be. your V? Negative 4, but yes. And then find your vertex if you haven't already. Put negative 4 in for all of your x values. Find your y values. Negative 1. I don't understand that. Negative 1. So that's going to be the point we put in the middle. Negative 4, negative 1. And again, we could, fill up the rest of your x's. Go backwards, go forwards. So backwards, negative 5, negative 6. Forwards, negative 3, negative 2. And then we could put each of these in here, but that would be time consuming, so we're going to just put this in the calculator. So negative x squared minus 8x minus 17, is that what it says? Yes, let's stick it. And then go into your table, second graph. We said the vertex was negative 4, negative 1, so go ahead and fill out your table. Negative 5, negative 2. Annabelle, can you hit new session, please? Thank you. And then once you have your table filled out, go ahead and start graphing those points. So it should look something like that. You wanted to draw in your axis of symmetry, you could. What would the domain of this be? Furthest left to the furthest right. What would negative infinity to positive infinity. So all real numbers again. What's nice about quadratics is that the domain will never change. It will always be all real numbers. The range is what changes. So for the range, what's your lowest, what's your highest? Negative infinity. Close. Negative 1. Or everything less than or equal to negative 1. Any questions on how we graph quadratics, find the axis of symmetry or vertex, domain, or range? So on the calculator, I'm going to show you this. So back in the table, let's say you had graphed it first or you were trying to check yourself. If you put it in and look at the table and look for where your y values repeat, I see my y values repeating, and it keeps repeating. If you do that and find where the middle is, that's always going to be your vertex. So you can always double check yourself by looking and seeing, is the middle of this your vertex? And then plot your points that way also. I'm going to show you one at Desmos here in 1 second. Go to this page. We're not going to do all of this, I just want to point out a couple things. So all the examples we did, we were given the equation, not the graph, and these you're given the graph. So if you're given the graph, you don't have to do the work for the axis of symmetry or the vertex, because the axis of symmetry is going to be the middle of both. So look at where does it split the middle, and that's going to help you find it. So what would the axis of symmetry for A be? Where is that middle? -2. So the axis of symmetry would be x equals -2. What about for graph B? +3, so x equals 3. Right? And then for our vertex, if you look at whatever the lowest or highest points are, that will tell you what the vertex is without you having to do the work to find it. So what would the vertex of graph A be? -2, -5. And the vertex for graph B? -4. And then to test your knowledge. So is this the lowest, the minimum, or the highest, the maximum point? Copy. Minimum. And then for graph B, is that your lowest, your minimum, or your highest, your maximum? Copy. Okay. Last thing, I'm going to show you how you could find this information in Desmos, and then you'll have time to practice. So. There we go. Okay. So let's say I just put in a random quadratic. If you click on this quadratic, it's going to give you 4 different things. Your zeros or x-intercepts, if you have any, your y-intercept, and your minimum or maximum, or your vertex. So you can easily check your vertex through Desmos as well. Make sure you utilize that. Right? You are going to be able to work on Khan Academy after you do this. So I'm going to give you these things, and then after you can work on any of these things. If you did not finish numbers 1 through 7 in the test nav, do that first. Then I want you working on the next 7, so 7 through 14. So if you haven't done any of them, you're now doing 1 through 14, using Desmos, trying to use Desmos on as many of those as you can. After you finish 1 through 14, you can be working on Khan Academy for this week, next week, or SOL 7E through the rest. I don't know if I said that earlier, but 7E through the rest is what's due next week. test math first, Khan Academy after. So you should have Desmos up, out on your laptop. If you need it on your phone, come ask me. Anyone have any questions on what we're doing for the rest of class? Make sure you're using this time wisely.